In this problem, we're given 4 different forces, and we want to find out what is the total or net force acting on the object. So we have a crate that is pulled to the right with a force of 85 newtons. It's pulled to the left with a force of 115 newtons. It's pulled upwards with a force of 565 newtons, and downward with a force of 236 newtons. Now, the first thing we're going to do when we're solving for these force problems and finding the overall net force is we need to find the net force for each direction. So part A asks what is the net external force in the x or horizontal direction. Now, to give an abbreviation here for the net external force, net means the total or summation. So to write down the summation, we're going to use a Greek letter sigma. That stands for summation or total. And we're going to find the total, the sum of the forces in the x direction. So I'll give a subscript here of x. Now there are 2 forces in the horizontal or x direction, just like your x-axis in math class. There's an 85 Newton force to the right and 115 Newton force to the left. Now we usually designate to the right as positive and to the left as negative. And so I'm going to have my 85 plus my 115 is to the left, so that's going to be a negative. And I get a total of negative 30. Now remember that the negative simply means to the left. So this would be the same as saying 30 to the left. Whether you prefer to write it as a negative or write it as an arrow is entirely up to you for this class. For part B, we need to find the net external force, but this time in the y direction. That's the vertical. Again, just like in math class, y direction, the y-axis goes up and down. Again, we're going to find the net external, so that means sigma f, and it's in the y direction, so I'll give a subscript of y. Now, in math class, we always have up as positive and down as negative. So we'll do the same thing here. We have a positive 565 plus a negative 236. This comes out to be a positive 329 newtons. Now another way of saying that is 329 up. Again, the positive means upward. Now for part C, what we need to do is find the overall magnitude and direction of those forces. So the way that we're going to do this is we have a total of 30 newtons to the left, and we have a total of 329 newtons up. So we're going to take those two and find the hypotenuse, which I'll label as F. But we also need a direction, which means we need to find the angle. We always find the angle where we started, at the origin. So these 2 arrows, the hypotenuse and the 30, makes a certain angle. We're going to find that. Now to solve for the F, the force, the magnitude, we're going to use the Pythagorean theorem, which says that the hypotenuse squared is equal to the square of the 2 sides added together. So now I'm going to take this 329, or 30 squared, plus the 329 squared. And when I solve for that, I get that it is 109,141. That's not my answer. To find just F, I need to take the square root of both sides. And when I take the square root of both sides, I get that the answer is 330.4. Now, the units for all forces are newtons. This is no different. That is only part of our answer. To get the other part of the answer, the angle, I'm going to have to use my SOHCAHTOA. So let's label the sides. We have the hypotenuse, which is our F. We have the opposite side. The angle is on the right, so the opposite of right is left. And then we have the adjacent side. That's the one touching the angle, but is not the hypotenuse. Now, according to my diagram here, the numbers I know are the opposite and the adjacent. So I'm going to use the tangent. But to get the angle, I need to use the inverse tangent, the opposite of the tangent. And I will take my opposite first, that's 329, divided by my adjacent, that was the second part with the TOA, and that's 30. If I take 329 divided by 30, I get 10.97. Now again, you can put this in your calculator if you have a calculator that does inverse tangent. Otherwise, you have to look up in the tangent column on your trig table, you have to look for the number 10.97 and see what angle that corresponds to. So again, in the tangent column on your trig table, look up 10.97 and see what angle that corresponds to, or type it in your calculator. Either way, you should get 84.8 degrees. Now, if I look it up on my trig table, I can only get as precise as 85 degrees. So it's okay to round it off. But there's the two parts to my answer. Again, it's no different than adding vectors from before. We're just now applying it to forces.